Hello students, I am Manish Kumar Malik. Today we will learn about projectile motion. In projectile motion, object moves in a plane and there are many objects around us which are in projectile motion. So here the first question is, what is a projectile? So answer is any object which is in flight after being projected is a projectile. Now we will take some examples from our daily life in which objects are in projectile motion. So you will find that there is a football which is in flight after being kicked by a player, and the forces which are acting on this football are gravity, and the second force is air friction. Gravity acts towards the center of Earth, that is perpendicular to plane in downward direction, and the air resistance is acting opposite to motion of the ball. In another example, there is a bullet which is fired from a gun, and the forces which are acting on this bullet are again the gravity and the air friction. To make our calculations simpler, there are some assumptions. Number one assumption is we will neglect air friction. So we will consider that the force which is acting on object is gravity. And the second assumption is we will take the value of g, that is acceleration due to gravity, as a constant. But we know that value of g changes with altitude. But to make our calculation simpler, we will take value of g as a constant. And the third assumption is we will neglect the curvature of the Earth. Although if I project any object from plane, it will land on a curved surface, but we will take it as a plane surface. Now, a projectile motion can be considered as a combination of two separate, simultaneously occurring one-dimensional motions. One which is along the horizontal direction without any acceleration, and second along vertical direction with a constant acceleration which is due to gravity. So we will begin our study with the simpler type of projectile motion, that is from ground to ground projection. In this motion, we will take an object and we will project this object from origin with an initial velocity u, which makes theta angle with the horizontal. Now our first job is to make this complex two-dimensional motion simpler. So we will resolve this two-dimensional motion into two separate one-dimensional motions. One along x-axis, which is horizontal direction, and second along y-axis, which is vertical direction. And we will take upward direction as positive. Okay. So downward direction will become negative. So first of all, I will resolve the initial velocity vector along x-axis and along y-axis. So component of initial velocity along horizontal direction is u cos theta, and component of this initial velocity along vertical direction is u sin theta. And in the same manner, I will also resolve the acceleration, and because there is no force along the horizontal direction, so value of acceleration along x-axis is 0, and because there is gravity along the vertical direction, so value of acceleration along vertical direction is negative g, negative because acceleration force is acting towards the downward direction.